Right, hello, welcome guys to this video on Linux basics for security professionals. As somebody who's trying to be a security professional or learning to become one, you have to be very familiar in a Linux environment. You have to be comfortable understanding how Linux works. A lot of tools are written for Linux operating systems. Therefore, it's essential you understand how Linux works, permissions, how to create files, run basic scripts. So we'll be talking about most of that in this video, but what I would encourage you to do is to, there are a lot of online resources, but there are two books that I would highly recommend if you really want to understand the basics of Linux. One book is Linux Basic for Hackers. You could probably find digital copy of these books in your library, and also another one called the Linux Command Line. The books are very similar in terms of the overall content, but it's worth having a look at both ones for this is, I think, is much more geared into security networking scripting, while this is just basically understanding how the Linux command line works. So I'll be demonstrating some of this here. So you can have it if you have any sort of Linux installation, or it might be the one provided to you in the labs. You have to log in with the user root, and the password is Tor, which is root spelled backwards or lowercase. So I would open up a terminal. Got my terminal here. So what are the basic things that you need to know? The first thing is you need to be able to know exactly where you are. So where am I? If you log in here, because we're the user root, you can see it's got this hashtag. The hashtag tells you this is a user that has got the highest privilege, like a root user or an administrator's shell. So in this scenario, we have I'm logging as root on Kali, and if I can see this hashtag, it tells me I'm the highest privileged user on this specific terminal. So if I do stuff like who am I, that tells you who you are. I'm root. I can also run commands like date to know exactly the date, and you can see the day here, the 23rd of January 2024. So you can run commands directly from a Linux terminal. We want to find out where we are, so we can use pwd, which I think stands for present working directory, and it tells us we are in the root directory. If we do a list command will list the files and directory. So here we can see the directories in the folder or the directory called root. You can have a look at the graphical user interface as well, where the outline of your folder is. So this is a representation of what we've got here. So you can see desktop, document, download, all of these folders here is what we're actually viewing in the command line. The good thing is you can recognize folders because these folders are highlighted in blue. Let's do something else like a long list, ls-l. A long list here as well gives us more information. We can see what we call the permissions on this folder. So if you see a D or in front of a folder in terms of the permissions, this is telling us this is a directory. So D stands for directory, R stands for write or for read, beg your pardon, W stands for write, and X stands for executable. So when you see this permissions here, tells us exactly that the user root, okay, can read, write, and execute files in this directory. So if you write a file into this desktop directory, this user that is logged in, root, has permissions to read, write, and execute. Also here, the group, anyone belonging to the group user root has read and execute permissions. Every other user, that means people that are outside the group root, they can read and execute files in this directory. So that is what the permissions stand for, but they can't write into this directory. They can read, but they can't write, because here we have a dash, here also we have a dash. So write permissions are not permitted for anyone who is not in the root group. Okay, so those are the sort of things. We also see the dates, timestamp exactly for when these folders were created. So we can move into a specific directory by using the CDs, change directory, and I can go into desktop. Right, if I go into desktop and I do a list, so again we can use pwd to check that we are in the root directory, and inside of the root directory we are in the desktop folder or the desktop directory. So it's basically what we've done is from the command line gone to the desktop and we've gone in here. All right, so if we do a list, we can see these two files which we opened up in the desktop. We can see them here as well. So that's basically what we're doing here from the command line. We're accessing folders, directories, and all of that from the command line. So if you want to exit one step backward, you have to do cd ... The ... tells Linux to move one directory backwards. So if I then click on enter, in this case, okay, and we do a pwd, you can see we're back into the root directory. We were here when we do the change directory desktop, and then we're back one step backwards now into the root directory. So to clear your screen, you can do clear, and that clears the screen. So what else? So let's try something else. We do a list, and we want to go into, let's go into this folder called tools. So cd tools, and we do a list. Now we can see we got some items in highlighted in blue, some are just in white. So like I mentioned, the ones in blue in this particular Linux distribution are folders. So this is a directory or folder, so it means we can go into this directory, and these are files. In order to know, we can do a list -la, and we can see here, so we have the ... and we have a dot. Like I mentioned, the ... is what Linux uses to go a directory backwards. All right, so you can see here, we can see the letter D as well, and that indicates this is a directory. And the ones that haven't got that, like this Python script, as you can see, hasn't got the letter D in front of it, so that tells Linux this is a file. So files, directory. This is another directory, this is another directory, and all of these are files, PHP files, Python files. So that is how you can identify from the command line folders and files. So we can go into a directory like this directory called crackMacExec. Click on enter. You can see now I'm in this directory. You can see the path to that specific directory. If I do a list, we can see the files inside of that specific directory. Okay. If we move a step backwards again to where we were, do a list, and we try to change directory now into a script. Remember, this isn't a directory. And we try to say, well, Linux, change directory into lean peas, and we do enter. It tells us straight away this is not a directory. You can't go into a file in this way by changing directory command. The change directory command only works if you're going into a directory, but not into a file. So we get that message. Let's have a look again into the list. We can then do the command file and do something like lean peas.sh. The command file tells us what type of file this is. So it tells us straight away that this is a shell script. It is a shell script, and that is what it is. If we do something else like we check a Python script in this case, dvdx, you can see the file command tells us this is a Python script. So the file command can be used to identify the type of file. Some files you might have will not have an extension, so it might be difficult to tell what sort of file they are. For instance, what I've got here, this OpenVAS credentials. Let's run that here, paste the file name, and see it tells us this is just a text file. So it hasn't got an extension. In that way, we can use the file command to understand what type of file it is. Okay, so let's go away from here and we do a pwd. We're back in the root directory. Do a list. We can see our folders. We're back in there. We can make a new directory. So using the make dir command, I'm going to make a directory called let's make a directory called project. Okay, project folder. Let's call it project folder. And if I do a list now, we got a folder called project. Okay, we can go into this folder now, do a list. There's nothing in that folder. We can have a look. Here we got the project folder that we just created, and there's nothing inside. The folder is empty, and that's why we do a list. There's nothing in there. We can then go ahead to create a file. There are different commands you can use to create a file, but one that is very easy to use is nano. So nano is a text editor. So I'm going to do nano, and I'm going to create a file, call this file file1. Now when I click on enter, we get this window that allows us to write into this file. So we got to get this text editor, something like Notepad in Windows, and then I could write something into here. So if you look at the lab notes, we got something like, I'm just going to write a few words, enter, and cat. I can put this into a file. In order to save the file, you have to exit. So you use Ctrl X, then click on enter. You say save modify file, yes. So you click on enter. So you click yes, and then enter, and that saves that file. So if we do a list now, we have a file called file1. We can run the file command on file1, and it tells us it is a text file. Okay, if we go into our GUI, we go in here, we have the file. We can open up the file, we can see the contents of the file. Okay, so what we did in the command line, we can actually verify that from the directories here. Okay, what else? So we can create another file by using nano, or you can use the command touch to create a blank file. So I'm going to use touch to create a file called file2. If we do a list, we have two files. One is file1, one is file2. How do we actually read the contents of file1? We can use the command called cat file1, and it displays the content of that file. If we do the same thing for file2, there's nothing in file2 because we created an empty file and we just get the prompt back. So now we have two files, file1 and file2. As you can see, they are not directories, they're actually files. So pwd tells us our working directory. We are in the root, and within root we are inside of the project directory. So these are basic Linux commands that we could learn from. So let's do something else and put some data into file2. We can run the command date, tells us today's date. We can then do date and say, well, instead of the output of date, put it into a file, and I'm going to tell it to put into a file called file2. So print the date. Instead of printing it to the terminal, put the contents of date by using this greater than sign. You put that content, output that content into file2. Click on enter. You can see we don't get the date, and that's because this output command here, or this output syntax, puts that into file2. So let's do a list. We've got two files, and now we can use cat file2, and we can see the contents of file2 is this. We can verify again, once again, by going in here and having a look at project file2. You can see we have the contents of date within file 2. So another basic stuff you need to know. So you need to know how to write into files, how to edit a file. We can use Nano to edit the contents of file 2. So if we do Nano, go in here, we can use the the keyboard cursor to edit the contents of the file. So I can edit this file and just say today is Tuesday. Control X, yes, enter. List. Now if we use cat to look at the contents of the file 2, we can see the contents has changed. Today is Tuesday. So basic Linux commands. So these are some of the things you need to learn how to do. So what else? Like I mentioned, let's go back to our list. We have file 1 and file 2. Let's open up text editor. So you can use text editor to edit a file, text 1. And here I am going to change this file to a script. So I'm going to do bin bash. Put bin bash on top to make this a bash script. And I'm going to say for I in 1, 2, 3. Do $. Just looking at my notes to make sure I don't do something that is different from what is in the notes. Okay. Let's exit this. I'm just going to bring out my notes. No. So I don't want to write into this file. I can just do a Control C, Control X. No. Let's have a look at what's in this file again. File 1. We still have got our contents. So let's go back into our notes to be sure we've got what we got in here. So let's make another file. I'm going to make this file called nano count. Okay. And we're going to write a simple script. For I in 1, 2, 3, do echo. Okay, so entering this text into the file called count, Control X, yes, and save. Now, if we have a look into do a list -L, count file 1 and file 2. Now, if you look at this file is actually a bash script. It is a script because if we do file count, let's see what it tells us. It tells us this is a born again shell script. So this is what bash stands for. It's a born again shell script. So we've got count. However, in order to execute this file, you have to run it this way. When I click on this, it tells us permission denied. And that is because if you look at the permission on the count file, there is no executable. You haven't got any sort of executable. So the user root hasn't, the file isn't executable. We can read the file. So we can do cat count. You can see the contents of the file, but we can't execute the file. And that's because because the permissions has not been enabled to make this file executable. So R is read, W is write, and X should be execute. So what we can do is make that file executable. So we can use this command called chmod, and we can say for all users +execute, add the execution permission. So the A stands for all users, and plus sign means add the execution permissions for the file called count. Okay, now let's run the command ls-l again. You can see initially, if we scroll back upwards, the count file didn't have any executable permissions. However, if we come here now, we can see it's got the execution permissions for all users, and it's gone green. Now, if we run the command count, if we try to then use /count to execute this file, it counts number 1 to 3, which is what we wrote into this script. So we just said for I, echo I for I, so it runs this loop and just prints out the contents of the 1 to 3 variable 1 to 3. So count is now executable because we made that permission executable. We can take away that permission. So what we did before, we can go back in here and use the minus symbol to say remove the executable permissions for the file count. Click on enter. If we try to then run count again, we get permissions. If we do a list, we can see the permissions have been removed. So you can see we can add permissions, we can remove permissions from a specific file, we can make it executable, we can make the file non-writable, we can make it so if you want to make the file non-writable, you can go in here and say for all users, remove the writable. Click on enter. If we do a list, we can see the file count can only be read, it can't be executed, and it can't be written to. So if you try to then do a nano count, let's see what happens, and we try to edit this file, Ctrl X, yes. Does he allow us cat count? It still allows us to do it, probably because we're still the root user and there are still some permissions still held within it. But for other users, let's say we got a different user that is not root, that user would not have access to write into that specific file. So we could add back the write permissions. For all users. And we can also add back the executable. And if we do a list again, we'll see those permissions are back, read, write, execute for that specific file. So those are some of the things that you need to remember in terms of permissions for read, write, and execute. There's one thing else I wanted to show is the SUID permissions. Now, if we have a look at the files that we created, count is read, write, and execute. We can make this file have what you call SUID, or make it an SUID file. That means you can make a file to inherit the permissions of the root user. So anyone executing this file would be executing it based on the permissions of the user root. So let's say, for instance, we have a different user. Let's create another user. Add user. And I'm going to call this user Alex. Okay, password. Make a password for that user. Okay, so let's change SU Alex. So we are the user Alex, and if we use ls.la, so I've changed my permissions now to user called Alex. We got count. Okay, so we've got the user Alex in here. Let's exit back to root. So because we created a user called Alex, we can exit back to user root, and let's remove the permissions now. for all users, let's remove the permissions for this file count. Let's go in as a user Alex again, change our user, and let's see. So no execution permissions. Let's see if Alex can execute this file count. Permissions denied. Okay, so the user Alex cannot run this file. So that is working as intended. So like I mentioned, we can make this file to be an SUID binary so that it inherits the permissions of that specific root user. So let's exit again, clear screen, and we do a list on our files. We can then use chmod, and we can then do u plus s count. Let's see what happens. Do a list .l. We can see this file now has gone red, and that's because this file has become an SUID binary. In some scenarios, you could have a network administrators might make a script an SUID binary, so that it could be a script which can do certain things using the permission of a root user, and they can create these files so that anyone executing that file will be using the privilege of a user. Similar in Windows, where you have things like run as, or you can say run as administrator. That's exactly what this file is doing. The file allows you to execute it borrowing the permissions of the root user temporarily. Okay, and this can be very dangerous. Someone can exploit this. So if they can write into this file and execute it, then they can then use the privileges of an administrator to compromise a specific target. So you can see now it's become this. Let's see if we can execute this file count. It says permissions denied, and that's because we haven't got the execute permission there. All right, we've already made it an SUID binary, so we have to then go in here and add the execute. And now when we run, let's do a list again to see. You can see now the S has gone from this, a capital or uppercase S, to a lowercase s. Now if we run count, it works as intended. Let's see if the user Alex will be able to execute this file. Permissions denied. Okay, permissions denied for this file. And that's because the file is an SUID binary, but Alex is not in the group, is not a root user, and he hasn't got the privileges to execute it. So let's do sudo count, put the password for Alex. Again, it tells us Alex is not able to run this file. So Alex is not a sudo user, therefore Alex cannot execute this. Let's try one more thing. Let's exit, and as the user Alex, let us do all users or others plus execute count. Let's put the command chmod su Alex count. You can see now Alex can execute that file because we've enabled permissions for all other users. So we're using others to execute that file. So if we do a list, all other users now have the execute permissions on that SUID binary file. So if Alex can write into this file, he might be able to then execute this file as the user root and take over this machine. So hopefully that gives you some sort of understanding into the basics of Linux, especially understanding the different permissions on the file, understanding the difference between the file and the directory, understanding some setting commands like list, check your present working directory, how to confirm what type of file is and is not, or the difference between a file and a directory. So thanks for watching. Take care.